So the next talk is about using GNU Guix on HPC systems. So by Ludovic and Piotr.
Right. So good morning, everyone. So this is again going to be one of these two people talks. And so I'm Ludovic Cortés, and Piotr Prince is going to talk afterwards about how we can use Guix on HPC systems where we don't have root access. So before I go into the details about what Guix is and all that, let me first recap what the situation is on HPC systems. So I'm guessing that many people here are familiar with what the situation is on HPC systems is not that great. We already had a talk this morning about how to improve things. Let me just describe a few key ingredients of what you can find on most systems nowadays. So this is a recipe. So the first ingredient is you have your supercomputer. It's super fast. It's wonderful. And so first thing you do is you install an old GNU Linux distribution, right? It's outdated, so people are going to complain. You know that right from the start. And it's also inflexible, right? If you're not root on that machine, you're not going to be able to do sudo apt-get install blah blah, right? So as an HPC user, you're not going to be satisfied, right? So sysadmins have come up with solutions to try and improve on that situation. So the main solution that we're seeing so far is to add a layer of homemade modules. So if you're not familiar with modules, it's this thing. So it's a set of commands that you can use from the shell, and you can say, okay, I want to load this specific package like GCC at that version. Yeah, you can select what you want to have in your environment. So that's already a great improvement because it brings a lot of flexibility that HPC users actually need, right? You have a machine with tens of users, they have different needs in terms of libraries, tools, and versions, and so you want them to be able to choose that. Now the problem is that to actually achieve that, sysadmins are essentially making a distribution of their own and doing that by hand, right? So they're compiling lots of packages by themselves, installing them in those special directories, and so on and so forth. So I don't know if it's the same for you, but my experience with modules on a cluster at work has been pretty much like this. So first thing, sysadmins are kind and they produce new modules, with packages that you actually need, but it doesn't work right from the start, right? So they first need to tweak the modules until it kind of works, and then it's like, oh wait, there's a runtime linker error. Like I cannot, run this command. I get an undefined reference error or something, and so they tweak things again. And some user complained that this particular piece of software needs to be compiled with different flags. So they tweak that module, and then new versions are out, so they need to rebuild everything. And then some user is unhappy, like you have a deadline for a paper submission, and just before the deadline, they decide to upgrade everything and to remove the old versions. And you're like, wow, I'm screwed. And so that happens in reality, right? So we have flexibility, but still the users can be in a hard situation, and so on and so forth. So that's not so great, right? And of course, you can have user-built software on top of that, especially with all the language-specific package managers. So Chris Weber yesterday was saying this is one package manager per child. It looks like it, there are so many tools available. So it's becoming a real mess. So fortunately, people have started to consider, changing the status quo. And we had a talk about Singularity this morning, and we'll have a talk about easy build right after. And so let's see how we can fix HPC cluster environments. So essentially, there are two approaches in use. So the first approach is to write specific package managers for HPC that address those problems. So the main ones I know of are EasyBuild and SPAC, right? And so these are package managers which are designed to be used on top of your old inflexible distro that you have in the first place. And that's really good because it solves quite a number of the problems I mentioned. So first of all, people can actually share their package recipes as opposed to having each sysadmin of each machine building things by themselves just for their specific machine, right? So people can actually share their recipe, their packages. And it provides easy ways to deploy software because anyone can install EasyBuild and SPAC on a machine without being root. So if you install EasyBuild, then you can, install your favorite packages on that particular cluster, and it works. All right. So that's a great improvement. Now there is some limitation with this approach. I think I'm going to maybe not make friends with the next speaker, but okay, we'll discuss that. So one of the main issues I can see that, well, so first of all, as I said, these are tools that are meant to be used on top of the distro that's available in the system, right? So every user is going to recompile software in their home directory, and that can be kind of annoying. That's kind of a waste of resources and CPU and storage. The second issue is this one. I don't know if you can read it from the back of the room, but this is a sample bug report from EasyBuild, I think, where people are saying, well, GCC libraries sometimes end up being, built with this flag and sometimes not. That's not a great situation to be in, right? We'd rather have something reproducible. And this is kind of unavoidable because as a non-root user on GNU Linux, there is simply no way you can get a fully isolated build environment. And so that's what you end up with. Right. Okay, and for good measure, this is the same kind of bug report, but for SPAC this time. And again, you see on some computers we have this behavior, and on some computers we have this different behavior. That's not a great situation to be in. So that was the first approach to fixing the HPC cluster environment issue. Second approach is to, I would say, give up on packaging. So what does that mean? Have you heard of that thing called Docker? Well, that's the story. You basically make an app bundle with Docker or with Singularity like we saw this morning. But what you're doing when you're using an app bundle is essentially you're telling people, okay, this is my application, right? It is all shrink wrapped, like Ricardo said yesterday. Essentially, you're providing a complete image that contains, all your dependencies, plus your application, plus, everything. And that's not so great because it prevents experimentation. Like from a reproducible science viewpoint, you not only want to be able to run the software as is, you also want to fiddle with that particular box here, right? And how do you do that? See, that's not, if all you have are the bits of this app bundle, well, that's not very helpful. And also, what if somebody comes and say, hey, look, I have my application also available as a bundle, right? And now how do you comport them, right? You end up with, maybe this box and this box is the same, but there's nothing you can do, right? They're not shared at all. So I think this solution is the wrong one, to put it simply. So at this point, the question is, can we have our cake and eat it too? And that's where Guix comes in. So how many people in the room have heard about Guix? Okay, that's, like half of the room. So essentially, Guix it's a package manager, and it's a transactional package manager that can be used as non-root. It allows you to manage software environments. It provides lots of tools and APIs to fiddle with, packages, environments, and so on. It has almost 5,000 packages available on 4 architectures, and we are providing binaries through continuous integration. So when you're using Guix, and if you want to trust the binaries we provide from our server, you can simply use them. It has a pretty active community with roughly 40 contributors every month. So I would say, it's pretty active. So how does that work? How much time do I have?
2 minutes.
2 minutes. Okay. So let me see. Just a very quick demo. Essentially, you have a command line interface that allows you to search for packages, to install packages. And this is happening as non-root, right? Okay. It tells you what environment variables you may need to set in your environment if you want to be able to use the software. And this is all transactional. So in a single transaction, you can say, I want to install something and remove something else, right? And that's a single transaction. And if you're unhappy, then you can always roll back. And this is all per user. So if you're on an HPC cluster, that means that everyone can run these commands for themselves, which is pretty nice. Okay, you can list the generations and finally roll back if you're unhappy with the new setup. Okay, so how did it work? Well, under the hood, all the packages are built in isolated environments. So this is really the crucial part here. So we are building packages in CH roots with separate namespaces and so on and so forth. So containers. Right? And what we get as a result is a unique file name in that store directory with that long hash, right? And essentially everything is going to be, well, almost everything is going to be bit identical for every person. Like if I build this package and Piotr build this package on a different machine, we're going to get the very same bits most of the time. So in a paper, Ricardo, Vermes, and myself wrote, we explain how this kind of tool can be useful in an HPC setup and what kind of goodies it provides. And so from an experimentation viewpoint, it means it has tools to create package variants. You can say, I want to use this package but with different source. I want to use this mums package, but I want to use a different dependencies, and so on and so forth. And you can have your personal packages as well. Okay, so Pierre is going to talk about non-root usage.
Hmm?
Can you explain this? Oh, okay. So just one last thing. So I was talking about isolated build environments, right? And essentially we have a build daemon here, and that's what provides isolated build environments. But that daemon needs to run as root, which is a source of problem on HPC machines where you cannot have this daemon running as root.
Right, and I have a solution. This is work. All right, so taking off where Ludo left off. Yeah, Guix basically installs in a path called GNU/store. Yeah, and this is done for reasons of reproducibility. We want everything to be exactly the same in every environment. But on a typical HPC setup, and I'm using a supercomputer at Oak Ridge, yeah, we're not allowed to run a daemon with root privileges. So the build system running on Oak Ridge is out. One solution we have, which is also described by Ricardo, who is here, you could mount a GNU store through NFS and have a build daemon sitting on a separate node somewhere, which is a possibility of creating these packages, downloading these packages, installing these packages, and making them available in the cluster. So if you have a slightly enlightened system administrator, this is a possibility. But if you don't, what do you do, right? So some years back with Nix, I tried. This is a link. Actually, these slides are online. You can download them. If you click on this link, it will take you to the Nix distribution, which is a sister distribution of Guix. Guix was forked of Nix 5 years ago. And I tried to use proot, and proot worked great. Yeah, so it actually slams in, a local directory for a global directory. Yeah, so the GNU store actually got remounted somewhere in my home directory, and that way I could run the software. But of course, every time this directory needs to be resolved, yeah, it slows down the process. So a couple of years back, with Eelco Dolstra, I'm also at FOSDEM here, I had a discussion, and he said, okay, you have actually a pretty unique path here, right? So for glibc 2.2.3, the libc library, the shared library, we have a path that looks like this. Includes a hash value. Yeah, and if you would scan the software, you could actually find this hash value. Yeah, so if you do look for the linked in shared libraries of the LDC compiler, the decompiler, you will see something like this. Yeah, so this also explains the way what Guix actually does, right? Yeah, it hard links all these libraries, yeah, so they are found separately on your system. So one thing we could do is try to rewrite these targets inside the files. Yeah, and Conda actually does this too, in some cases. Yeah, and the only dependency you actually is left is the Linux kernel itself, because actually when we ship this, yeah, glibc is included, and the Linux loader, or shared library loader is also included there, yeah, which is this one, load Linux. So what happened here? Yeah, the path is a fingerprint. We scan all the files, replace the fingerprints with something else, which has a relative path. So this is /GNU/store, and here I have a home directory opt ldc test. Yeah, and it worked. Yeah, I mean, there's a tool written by Elke called patchelf, which actually can do this for you on ELF files. And the link is here. And in textual files, like in Ruby and Perl, there's also these long file names, these fingerprints, which can also be replaced easily, of course. And unfortunately, when it comes to Python and JVM, it doesn't work that well. Mostly because they're not zero terminated. Yeah, and you cannot just, without knowing the internal file format description, you cannot just expand these files. Yeah, so one night I had an idea. I said, well, why don't we keep the file path at exactly the same size and patch everything? Yeah, so basically, it's a second insight. Yeah, so you end up with something that has the exact same file length, string length. Yeah, so home user opt gets replaced, and the hash value basically gets cannibalized, yeah, to make it the same size. Okay, and it works. The only downside is that the prefix can be up to 40 letters long. Yeah, because then your hash value is gone and the prefix. So I've put in an example. It's online. You can do it. Yeah, so you can download the latest decompiler, which was released only a few days ago. It's a 24 megabyte download. It unpacks into 140 megabyte and installs in 3 seconds. Yeah, so, and the installation, of course, is the rewriting of the path. And it comes with batteries included, right? Because all the shared libraries are with it, yeah, the glibc included. So you don't have this typical problem that you get these glibc incompatibilities or LLVM incompatibilities, because the kitchen sink is just included. Yeah, so far I've tried LDC, I've tried Ruby with SSL and Nokogiri, which are also notorious. And then a Sambamba tool, which is a tool that is written in D, in the D language, and it's actually deployed among many HPCs around the world. Yeah, and this tool until today we've actually done by statically linking in the libraries. Yeah, so it's a binary without any references to outside. But the current version is actually we're using now to debug problems. Comes with the shared libraries, and more is coming. Yeah, so Oak Ridge actually takes a great interest in this project. Yeah, so maybe that we get some support from them. So Guix also has cross-compilation. It's built in, like Ludo said. So you could say something like Guix build, and then set a target for the MIPS in this case. Yeah, and then compile something. And then you move it to the new architecture, and it will just run. Yeah, so I think in the foreseeable future we will have PHY support and also NVIDIA. So what does this actually give us? Yeah, the thing to understand really clearly is that Guix is an existing distribution here. So people are using these packages every day. There's thousands of people who deploy these packages. There's maybe 100,000 people who use these packages. Yeah, so unlike many other systems like EasyBuild, which is kind of ad hoc, you have actually a completely reproducible and tested environment. The only trick that I'm doing is rewriting the prefix. Yeah, so if there's any issue with the software, it could have to do with the prefix itself, but so far we've not hit any problems. And I want to conclude that 2 simple ideas which happened at FOSDEM can come a long way. Then we can carry beyond HPC. You can easily see this happen. You can create a repository of binary packages, and these can be one-click installs. And essentially they are already, but the install script is inside the tarball at this point. You can have it outside. You can ship software easily. Yeah, maybe we get it in Linux. Thank you.
Thank you, Piotr and Ludovic. Any questions? On the use of geeks for HPC? I actually have a question. So I'm one of the people that opened the bug report that you showed. I'm the easy build release manager. Actually, you're hitting good points. Isolation is a big issue. And there are actually people now who combine easy build with Nix, which is very close to geeks. So a couple of guys in Canada are doing exactly on top to build all the scientific software with. Is that a use case that makes sense to you, or do you say just throw out easy build and go the geeks or Nix way?
I don't know. Oh, sorry. Yeah, so about using Guix as a backend for EasyBuild, I don't know exactly how that could work. I guess I don't know EasyBuild sufficiently well. Yeah, I don't know. Maybe it would make sense. Do you want to comment?
Yeah, with Conda we're seeing the same thing, right? So, and I think with both these systems you have a real problem with bootstrapping, yeah, because you have to bootstrap from the underlying distribution, right? So one thing Geeks can do immediately is create the bootstrap environment, yeah, and build up from there. And then slowly, you know, when you have Geeks available, you can start replacing, you know, the stuff that's already there. You don't have to do again in EasyBuild.
So how much scientific software is now supported and in Geeks, like readily packaged?
Ricardo?
A lot.
Yes.
Right.
Whatever we need at the NBC is mostly bioinformatics stuff, but there's other scientific software as well.
Right, so there are a few HPC deployments already, and people, mostly bioinfo people like these two people, have been packaging a lot of bioinfo plus HPC plus algebra software.
So there are, I think, about 400 R packages in there.
In principle, we could have all of them.
Yeah.
It's just 400 that are properly reviewed.
It's just somebody has to do the work, right?
Well, Geeks actually also has a generator for packages. Yeah, so if an existing R package and you want to pull it in, most of it is generated.
That's the easy stuff.
Yeah.
So I mean, R packages, Python packages, that's trivial. You can write a generator for it. And
Exactly.
EasyBuild is very easy as well.
Yeah.
But there's other stuff in EasyBuild that I'm reasonably sure it's not in Geeks yet, which is really, really nasty. Which has like interactive configuration scripts. And, I mean, Guillermo is going to talk about some of them.
Right. Have you packaged the Node package manager? NPM?
I'm not sure. I would have to check. It's possible.
We've already had 2 people die on the way, right? Yes.
Real question. I have to install R on customers cluster in the UK. That's really what I have to do this week. Would you say I should use EasyBuild? I'm going to use EasyBuild. Should I then use Geeks? Can I start using
If they don't want to use RStudio at this point, I would suggest Geeks. Yeah.
Why, Sean? Why?
Sorry?
Give it why?
Why?
Yeah.
I know why he's giving a talk on
Maybe Ludo should answer this.
Right, so, yeah, I mean, obviously you should be using Guix. That's pretty obvious. But I mean, the reason is that you would get, so the advantage you would get with Guix over EasyBuild is that reproducibility thing, right? So we have R plus lots of R packages, and if you install them with Guix, it's going to be reproducible. You know that it's going to work just like on every other machine of Guix users, right? There's not going to be bad surprises just on your specific machine. Now you will also, I mean, as it is now, you'll have probably to run that build daemon as root, which may or may not be a problem in your case. But the solution that Piotr showed is precisely one of the options we want to offer for people who cannot run the daemon as root.
Unless customers use it, won't they'll get it.
Yeah.
I'll have to build this. But I
So-
can make it cluster wide with Geeks as well. This is not for one of you. I can make it cluster wide again.
Yeah, right, yeah. You can make it cluster wide.
Yeah, so we have a couple of more Geeks talks tomorrow in the Garl dev room. Yeah, so if you're interested in the technology, you'll get a lot more out of that.
I would like to point out is that things are a difficult problem, they're always contextual, and I guess even Geeks would also fall in the trap. If you build on slightly different architectures, I'm talking here about x86, 64-bit different microarchitectures like, let's say, Sunday bridge, Ivy bridge, that kind of stuff, you can easily end up into graph points.
Yeah.
So you must not miss that part of the discussion.
Right. Oh.
That's all we have time for in terms of questions. If you have further questions, you can meet up with Ludovic and Piotr outside. Keep the discussion going. Thank you very much.